Hi, welcome to CSCI100 Lecture 13. This lecture's goal is to get you prepared for the project that you'll start on Thursday, which will involve working with images and creating filters, Instagram filters for those images. And so today we're going to cover the last couple bits that you need in order to do that, which is image I/O, so image input and output. I'll show you a little bit of working with images. And then I'll also cover the topic of doc strings, which is more tied to style. Before I dive into image I/O, a word about interview prep. So for those of you, if you're really serious, you want to pursue a software engineering internship this summer, I'm going to provide some more practice resources for you. So either you really want to push yourself and get yourself ready for internships, or maybe you have experience and so you're a little bored in this class. I will be releasing over the next few days practice problems on Mimir that are mock interview questions. They're the sort of questions that you would get asked in an interview. And these assignments will also include some video walkthroughs, I believe, that I think either describe the problem or help you solve the problem. And you can just go ahead and do them at your own pace. They're not mandatory for the class. And I just encourage you to do them if you're interested in an internship. Also, this Friday, so today, that'll be October 15th, at 11:30, there will be a half-hour talk given by a Googler. His name is Mark Cohen. And he's going to give a talk on what interviews are actually like. So what is an interview made up of and what are they looking for? And this is a great thing for you to attend if you don't have any practice yet with interviews. After this talk, you can then go ahead and go to the mock interviews page and sign up for a mock interview with a Googler, and you'll know what to expect. Image input and output. So last lecture, we conceptually learned of this idea of an image being made up of a grid of pixels. So this is a 2D list, a grid of pixels. And each pixel is itself a list of 3 color intensity values. So there's the red, green, and blue, which is why they're called RGB pixels. And so the list of three numbers here indicates how red this pixel is, how green this pixel is, and how blue this pixel is. And so a pixel that doesn't have any of the colors, so 0, 0, 0, is black, so no intensity at all. And a pixel that has all 3 colors, 255, 255, 255, to their maximum is white, which is what you get when you mix these 3 colors. And so again, I'll just repeat this, a grid of pixels, which is why you have first an outer list where each element in this list is a row starting from the top. And then each element here is itself a list, which represents the row, and every item in the list here is one of the pixels. So this is pixel 1, this is pixel 2, and this is pixel 3. So don't get overwhelmed by all the commas here and what's going on. Look at the open brackets and the elements that are separated by commas inside of these brackets. And then finally, each pixel is made up of these 3 values, R, G, and B. So really, it's like a 3-dimensional list, but think of it more as a grid of pixels where each pixel happens to be a list itself. Now, when you're working with files on your computer, you just see them in the browser here. And so the question is, how does the computer store these images in the file system? And the file system refers to this storage that you have where all of your files are. Or if you're on a Mac, you look in Finder. I'm not sure what it's called for Windows or for Linux. So here I will take an aside and talk about memory, different kinds of memory. Memory versus storage in particular. So memory is this thing that we've been talking about all along. It's known as also RAM, RAM, which stands for Random Access Memory. And it's this type of, it is memory that is short term. So it's only used while the program is running. It's very fast, but it's only temporary. And so when we go to Python Tutor, and we write some code here, name, comma, x, just any amount of code here. When I run this code, this thing on the right that you see, frames and objects, this is referring to this memory, to this RAM, random access memory. And same thing to any objects that show up here on the left. If I were to also make a list of some sort. These objects are also all in RAM, and that's because they're only used while the program is running. Storage, on the other hand, is what we call the longer term memory. So all these terms are kind of overloaded, and you'll hear people who are less experienced just use the word memory. There's memory and then there's storage. And you'll hear the storage called hard disk, hard drive, SSD, all these different things. This is the kind of storage where files persist, still exist, even when you turn the computer off. So memory, RAM, does not persist if you turn your computer off. It just goes away. In fact, it goes away when you're done running the program that you're running, whereas storage stays forever. Because of that, it's slower, but you have a lot more of it. And we use RAM memory because it is much faster for when you're running the program. So storage is for storing files long term. Memory is kind of like scratch paper, and it's where all those frames that we talked about are stored. If you're curious, you can see how much memory you have by going up to the apple in the top left corner if you have a Mac and clicking About This Mac. And then you should see here in this overview where it says memory, it'll say 16 GB, 16 gigabytes on my computer. Yours may have 8, it may have 4. Usually it's a power of 2, so it could have 2 if it's a particularly old computer. So this is your memory. On the other hand, your storage, you can see your storage in that same window. So Apple, About This Mac, storage. And here it'll show you how many gigabytes are available out of your total memory. And here you see it says Macintosh HD. That stands for hard drive, which was what I told you. Oftentimes hard drive is the kind of storage that we have. Could also be SSD, so solid state drive. So all different kinds of memory. Flash storage, this means it is actually a solid state drive, which just is the name of the technology, of the hardware that implements this, this storage. But here we see 251 gigabytes of space. And there's our device. Now, oftentimes, these are almost always a multiple of 2 because of how, just because of how memory is created and how things are stored, often a power of 2. Well, you might ask, Alex, hey, why is this 251 instead of 256? Some of the memory some of the storage on your hard drive is actually reserved for some special purposes. So what's left for you to use is 251 gigabytes on my particular Mac. Okay, so going back to this file finder window, everything that you see in this file browser is in storage. So everything that you see when you look up your files in this browser is in storage. You won't ever see what's in the RAM memory directly. That's just what's used when you're running your program. And the way that you should think about RAM is it's like the best way to see kind of what's in RAM is to use Python Tutor for now. As you get further on in your computer science curriculum, you'll come across other tools that you can use to look inside of your computer and see what is stored in that RAM while the program is running. But it's really only just for software engineers like you to be able to figure out bugs in your code, which is what Python Tutor is so handy for also, because it steps you through your code. Now that we have that context, so these image files are stored in storage, and you've probably seen all these different possible endings. So .png, .jpeg, sometimes there's an E here as well, that's the same thing, JPG or JPEG, .tiff, .raw, and others, all these common names, all of these different types of memory, of storage, they just define kind of how we map these pixels into ones and zeros in binary. Everyone agrees on the screen there are pixels, and so that is the idea for how we store an image. An image is a grid of pixels. But these different file formats choose different ways to store these pixels as ones or zeros. Some of them use something called compression, where they actually store fewer than all of the pixels, but they have a way of reconstructing them. So for example, they might store, okay, I'm going to remember that this block of pixels is all black. So I don't have to write 0, 0, 0, 0, 0, 0, 0, 0, 0. I could just specify that this range of pixels is black. And maybe that will take up less space. And so that's why some people use JPEG, some people use PNG. TIFF and RAW are both oftentimes very large image formats that store a lot of memory, take up a lot of space in memory and storage. This is where modules come in very handy, and this idea of abstraction comes back. So in this class, and just in general, we use modules to read in these images, and this module is going to abstract away all of these differences. So it'll always provide you a two-dimensional list of pixels, where each pixel is this list of 3 items. Now, in this class, the standard library to use for this is called PIL, which stands for, library Python, which stands for, I think, Python Imaging Library. And actually, so, nowadays it's actually called Pillow. And this is the standard thing that everyone uses for reading in images and working with images. Because it can do a lot of different things, to simplify it for you, we're going to provide our own layer on top of that. So a module that uses that module that just gives you a way to read in pixel values from a file, and then gives you a way to write pixel values back to a file. So you read them in as a two-dimensional grid of pixels, and you can write any two-dimensional grid of pixels back to a file.